Good afternoon, everybody, and thank you for joining us for today's Grid Curtailment webinar. Today, Ryan Stankovitz, our applications engineer, is going to be giving the presentation. I am Sue with our sales department, and please feel free to put any questions you might have in the question box. We'll try to answer those as we go along, and we will also have a Q&A session at the end. Ryan?
Thank you, Sue. Welcome everybody for coming on out today, and glad you can join me for this. We're going to talk about the different modes the Rosie has to help you, limit the use of the utility grid, minimize expenditure on utility fees, if you will. We will, like I said, try to answer questions along the way from the question pane, but we also will open it up at the end as well. So my obligatory slides of who we are. Some of you are probably familiar with this very well by now, and maybe some of you are not. But we get our roots from all the way back, trace days, out back. We even helped with the Magnum Energy equipment, as you might see in that pile if you look closely. Always just seem to be on the front of innovation when it comes to battery-based stuff. One of the largest manufacturers of PV combiners. That is actually one of our mainstays, and of course our what we call world famous classic charge controller. But we're pretty proud of that. We're somewhere up around 80 or 90,000 of those built now. So a lot more. This picture here is just some of the stuff Robin designed before Midnite. I don't actually think there's a Midnite product in that picture, but this just shows some of the stuff he had his hands in. Some of the stuff that never even made it to market, like that little blue inverter right down here by my mouse. That was a trace inverter that was supposed to mount on the frame rail of a trailer truck that never came to market. And who am I? Well, most of you know who I am. I don't usually talk a lot about who I am, but I'm a master electrician, extra class amateur radio operator, many off-grid installs under my belt. I've dabbled in construction/electricity my whole life. That's what I went to school for. That's what I've always done. I installed a lot of renewable energy systems in Maine when before I went to work for Midnite, and even quite a few after. Robin always encouraged us to stay current on everything and understand the products, the markets, the competitors. And that's kind of what I've done. I've done a lot of that. I've got a lot of experience with a lot of different brands of equipment and just try to bring that all to you guys. I've been here now, I don't even know how long. I started with Midnite pro bono before Midnite really got going, and I came on as an actual employee when we started selling classics, which I think was somewhere around 18 years ago, but I don't know my hire date. It's been a while anyways, let's put it that way. So here's what we're going to talk about today. We're going to go through this step by step, if you will. We're going to explain what I mean by grid curtailment, some of the ins and outs of it. We're going to go over the specs of some of our core equipment real quick, and then we'll go down through. We'll talk about grid support. We'll talk about LBX, which is low battery transfer, and then we'll talk about time transfer and some of the stuff that rolls in with all of that. And I do have a question. Wonder how many spit that out. Wonder how many ham radio operators work for Midnite. Bob is a silent key now, but he was a ham. We have Andy, myself. Sue's actually a licensed amateur radio operator. A lot of our engineers were. At one time, we even had our own ham radio club in the building. We had actually had enough employees that were. I think we're probably down to 4 or 5 at the moment. But the engineering lab still takes it very serious. If you was out there, you'd see they have dipoles set up over all their test equipment and so on and so forth. And I also have a question about similar webinars for the all-in-one inverter, and we will be coming up with that. I was actually just chatting with Logan Bryce. We're going to start putting together a slide deck for that, and one of us will be presenting that hopefully pretty soon. So stay tuned for that. So we'll be letting everybody know as that comes around. So what is grid curtailment? Again, what we're really talking about is if you've got a $100 a month light bill and you want to put in some renewable energy equipment and you want to minimize that light bill, what we're trying to do is curtail the use of that grid, minimize the use of that grid. We're trying to not charge the batteries from the grid. We're trying to prioritize the renewable energy, and we're trying to maximize the amount of energy we use powering loads from the renewables and minimize the amount of energy we use from the utility grid. It's always more expensive to charge the batteries from the grid than it will be from the solar, if you can. So that's just kind of the core of this, what we're trying to do. And I'm gonna kind of go over why you might want to use one of the three modes versus the other one. I'll hit on some of it here, and then we'll go dig deeper when we get to those modes. But essentially, we can set it up to ignore the utility during times of the day using time transfer. So let's say your utility says, hey, between the hours of 5 and 8 p.m., we're going to charge you 3 times the normal rate. Well, we can set Rosie up to disconnect from the grid at 4:45 and reconnect at 8:15 so that you never use that expensive electricity, right? We can dig into the battery a little bit, charge it back up tomorrow. Grid support, for example, will blend power with the grid. Some of the modes like LBX disconnect from the grid. So there's reasons for both of those, and we'll talk about them. One of the things to keep in mind is when you are using like grid support, because grid support is a form of cell. So what grid support does is it's going to sell out of the inverter until the loads are satisfied, and it tries to ride right on that hairy edge of not exporting but powering all your loads. So what's been found over the years is every inverter that does this needs some amount of offset, if you will, where the first amount of power always comes from the utility grid, and then we power the loads. Because if you have, say, a 5,000 watt clothes dryer on and the electric element shuts off, that bounce for just a split second could cause the Rosie to sell to the grid if it doesn't have a little bit of room to work. And that's what we call, that I call it like a forward bias, but it's the first 150 to 200 watts will come from the utility grid. So if you are a power miser and you use hardly no power and you're in grid support and you're going to be sitting there like, why am I running 150 watts from the grid? My load's 150 watts. LBX mode may be more for you. If you're kind of a power user, like myself, for example, I have an electric clothes dryer, I have 2 air conditioners, I have hot water heater. All that stuff is electric on my system here in Florida, and I set up with grid support because that couple hundred watts is pretty minor to me. I'm trying to just really maximize what I'm doing, and grid support allows me to do that because it's more of a teeter-totter, where if the two people weigh the same, the balance is in the middle, and it can balance that out, and it can really split that, which we'll talk about a little bit later. Grid support gives priority to a full charge where LBX does not, and I'll go into much greater detail on that when we get to those modes. But that is something that can be important if you're using like a lead acid battery versus a lithium battery. We may need to treat them slightly different. So we'll jump through some specs, and then we're going to go and we're going to dive right into these modes. So most of you probably know these already, but I'll try not to put you to sleep while we talk about this. But the Rosie is 120, 120, 240, 120, 208, 2 legs of 3-phase, 230 volts, 50 hertz, any of those options in a single inverter. So you can go into software, you can tell it you want it to be 120, 208, or you can tell it, hey, I want you to be 230, 50 hertz because we're going somewhere else. It'll also stack. Right now we're supporting 2 officially, but we are now testing 6 in the lab in parallel for 120, 240. So that's 42 kilowatt inverter that surges 3 times its rating, if I did my math right. And you can also stack 3 currently for 120, 208 3-phase, and we are getting ready to start testing on a 6-stack 3-phase as well for large 3-phase systems. So a lot of stuff happening right now in the Rosie world for expanding into the larger systems. We also have some pretty exciting, I don't want to say low cost, but pretty budget-minded kits, if you will, where we're mixing our power flow batteries and the Rosie and the hardware. I think Sue sent some constant contacts out about that. But if you're looking to do a system, reach out to us, because we do have these kits where we bundle everything together, including the power flow batteries, and offer you a pretty substantial discount by doing that. So we talked about the voltage settings. It is 7,000 watts. It is 48 volts. It will surge 3 times its rating. It does have a 120 amp battery charger built in. Of course, this true sine wave, I don't think you can buy an inverter today that isn't. Well, you probably can, but not an actual large scale inverter. It does carry UL 1741, UL 458, and CSA. The 458 is only on the mobile Rosie. The mobile Rosie carries 1741 and 458, where the regular Rosie only carries 1741. Does have some low-speed fans, and it will do state of charge monitoring with the Whiz-Bang Junior. It'll also do closed loop, so if you want to use our power flow battery, or you've got some EG4s, or whatever the case may be, it'll close loop with any battery that can speak pylon protocol, which is probably one of the most common protocols in the market today. It's almost becoming a standard as I can see it. It is a die-cast aluminum enclosure. It does have matching breaker box available for it. It also has a full-fledged 2-wire gen start, if you need that. Battery temperature sensor is included, and it does speak CAN bus. And like all of our other equipment, except for our power flow and our all-in-one, it is built in Arlington, Washington, right in the U.S., so American jobs. So to pair with that, if you're going to do some grid curtailment, you're going to need some PV to charge those batteries and power those loads. So we have several options for you here. Our flagship products that go with the Rosie are our Barcelona and our Hawke's Bay. They're both 600 volt MPPTs. They do have an optional arc fault and ground fault protection kit that you can buy with them. So they will do arc fault and ground fault. The ground fault is unique, and it is, I believe, the first controller. Well, maybe the Snyder 600 volt controller does this as well. But the first controller to allow you to solidly bond the battery negative with the new code and the new terms for grounding between reference grounded and solidly grounded. I don't want to go way down the rabbit hole, but there is a good reason to use the newer ground fault detection. MPPT range, this says the MPPT range. I got to fix this slide, but it says it's 185 to 585. The unit will track down to about 200 volts. So in a perfect world, I would start out at 300 volts VOC as your minimum. 600 is your maximum. Those are kind of your two numbers you're shooting for. The controller will run all the way to 600 volts. If it's at 601, it will not turn on. So you want to consider temperature corrected PV voltage. And they are 48 volts only on the output. They're meant to pair with the Rosie. They both data log for 360 days. They both speak. That was something Robin felt strongly about. They are both ETL listed for US and Canada. They also have remote battery voltage sense. They also have a battery temperature sensor. And they come with the MNGP2. So we didn't talk about the MNGP2, but it's that display right in the middle there that has the buttons and the knob. And you will need one of those for the Rosie. So if you're not using one of these two charge controllers, you'll need to buy an MNGP2 to go with your Rosie. If you're using one of these, they all network together, share programming, and can use a singular display. Or if you're putting in like 2 aux bays, you could move one display in the house, for example, if you wanted to. The difference between a Hawke's Bay and a Barcelona is truly just the Barcelona is a dual input 200 amp output MPPT charge controller. The Hawke's Bay is a single input, and it comes in 2 models, a 90 or 120 amp out. So that is the only difference. As you can see in the breaker box, you just get an extra PV breaker, and that's it.
One little side note, if you want to do remote monitoring with the Rosie, the Hawke's Bay, or the Barcelona, we do have a partnership now with Solar Assistant on that.
Yes, that's a good point, and if we have time, I can try to pull that up and show you what that might look like. So we won't spend a lot of time on the Classic because, like I said, we've been doing this for about 15 years, maybe 18 years, and we're up around 90,000 of these out the door now. Just know they come in actually 6 models. You get a regular Classic and a Classic SL. The SL stands for sort of light. So some of you may remember the classic light that had no display, and that was kind of a nightmare for tech support because the customer never had a voltmeter. And when you're trying to get the customer to troubleshoot with no voltmeter, so we came up with the idea of the Sorta light, which was a regular classic with a bunch of stuff stripped out of it that was just a solar controller. But both of those models are available in 150, 200, or 250 volt operating voltages. That's your VOC, if you will. So if you got an array that's at 200 volts VOC and it gets cold enough there where it drops to it's going to be like 240 volts, then you'd use a classic 250. The classic 150 is the most powerful and the least expensive. So that's something that's one of those things even today at 80 or 90,000 of these things out the door. A lot of people still think the 250 is more powerful because it's a bigger number, but it's actually less powerful into the battery. It just can handle a higher PV voltage. The Classic will support 12 to 72 volt nominal battery voltage. It will charge virtually any battery we've ever found that needs to be charged. It does have built-in ground fault and arc fault in the regular Classic. The SL only has ground fault. Solar, wind, or hydro modes, manual or auto EQ. The Classic is fully internet capable, so you can connect that up to what we call My Midnite, which is our cloud-based portal. The rest here, 380 days of history. It does speak Modbus if you want to talk to it directly. The rest of the products speak CAN bus, so that is a difference. Parallel operations, they will network together if you have multiple Classics. And it is ETL listed for the US and Canada, and as the other products, it says made in America as well. So some other things to consider when you're doing grid curtailment, and the title of this slide really isn't fitting. I couldn't come up with a really good name for it, but these are just some of those tidbits that I wanted to throw in there that are gotchas, if you will. Consideration for how you're doing your state of charge calculations. If there's a Rosie in the system, which there probably is if we're talking about grid curtailment using the Rosie, and you're not doing closed loop, I would suggest letting the Rosie do the state of charge using Whiz-Bang Jr. If you're doing closed loop, then of course the battery provides that state of charge. If you're not comfortable with the state of charge, these settings can also be programmed to run on battery voltage, which is a little trickier on lithium, but it's still doable, and sometimes can actually be a benefit. And that's my next point here is that BMS, a lot of BMS can drift, and this is a phenomena that I wasn't familiar with until about 6 months ago. And a customer asked how our battery managed, state of charge drift, where a lot of the others don't. And what I didn't understand at that time, and I do now, is that most lithium battery BMSs, the resolution is poor enough that they don't actually read when it's really low current draw. So let's say you have 4 of our PowerFlow 5 batteries, and you're a real power miser, and you're only drawing 150 watts through the night. That 150 watts probably isn't enough for those 4 batteries to recognize, and they will not actually drop their state of charge as you go through the night. And why I mention this is if you're running in like an LBX mode or something and you're using state of charge, you can actually get to a point where you can run the battery into a low voltage situation and it shuts down when the BMS still thinks there's actual percentage of the battery left. We're combating that on our batteries by adding a lookup table to, periodically sanity check state of charge against battery voltage. But that's a phenomenon I've seen many times over on my EG4s. It took me a while to understand what I was seeing, but I was running in grid support mode based on battery voltage. And a lot of times EG4s would say they're at a lot higher voltage than a higher state of charge than they really were. And that was because of that, that low power drift, if you will, or lack of recognition of the current draw on those batteries. So that's something to be aware of. That usually gets fixed by a full charge, of course, because if the BMS thinks the battery's full and you keep putting power to it, if the cells are below their voltage, the BMS will keep providing them power and charging them, thinking they're low. So that usually auto corrects every time you go to a full charge, which a mode like LBX doesn't do a full charge. And we'll talk about that in a minute. So I'm going to dive into the 3 modes now, and I'm going to go through How, what, and why. I'm going to give you an example. I'm going to show you the steps that you'd use to program the custom settings, and we'll go through all three. So grid support is probably one of the more elegant ones because it will actually blend power with the utility grid. So if your goal is to keep your battery at a 90% state of charge in case you have an outage, but you still want to use every little ounce of solar power that's being brought in, you can set grid support for 90% state of charge. And anytime the battery is at 90 or above, the solar power will be transferred right straight through to power loads. If the loads exceed the amount of solar power, the balance would come from the grid. So if you have a 1,000-watt load and you have 500 watts of solar power, you pull 500 watts from the grid. Or if you set the state of charge lower, of course, it will bring the battery down to that state of charge. So if you set it for 50%, like I do here, and we'll do in our example, then if the battery's at 90%, all the loads will come out of the inverter because it will pull the remaining from the battery until the battery falls to 50%, and then it'll maintain that 50%. It does allow you to use the batteries we just mentioned, and it really does squeeze every last drop of renewable out of the system, whereas like an LBX mode or a time transfer mode, you can end up leaving some on the table depending on how full you want your battery. And all three of these modes are fully automated. No intervention by you needed. The only intervention I'm going to say that you might want to do is the modes that do not prioritize charging over the mode itself. Let's say you're up in New England somewhere and you guys have got an ice storm coming. You may want to go in and disable grid support and force a bulk charge to do a full charge on the battery so you can start off that storm with the most energy stored that you can. Some of the things that we're going to need to do is to properly set up the charger with a short float time. This is one that I get a lot. The Rosie, by default, has a 24-hour float timer in it. So what that means is that if a Rosie connects to the grid, it will do its bulk charge. Then it will do its absorb charge for the absorb time you have programmed. Then it'll drop into float, and it will stay there for the remaining of the 24 hours until a new absorb cycle is triggered at midnight. And you have to remember that the charger takes priority over grid support. So in this mode, grid support is secondary to your battery charger. So if you had a set of lead acid batteries and you wanted to make sure that they got full every now and then, you could set up grid support to drain the battery to like 50%, and you could set rebulk to like 40%, for example. And then when the battery dipped down to 40% through the night or on a couple of cloudy days, that would force another full charge. It would actually do that 3-stage charge on the battery, then go back into grid support, whereas LBX will actually disconnect, as we'll show you in a little bit later. So that's something to keep in mind, is that in grid support mode only, the charger takes priority over the support mode. And you do need to set up rebulk properly, because what you want to do in a perfect world with grid support is you want to have basically the system maintain itself from the renewables and ignore the grid, right? So like in my case here, I dropped to 50% on the state of charge in the evening, and then I roll loads back over to the grid, but I do not charge the battery. But let's say you were in an environment where you got 4 or 5 days of snow, and then just all of those parasitic draws on the battery and everything slowly drag the battery down. That's where rebulk comes in this mode, because then what would happen is once you hit rebulk, you would start a new charge and fill that battery back up. So that's something to keep in mind. That's kind of the nuance of grid support. The other nuance of grid support, like I mentioned, was that you will have that 150 to 200 watts coming from the grid to power your first 150 to 200 watts of load. Then it will prioritize, the PV after that. So here's one of my poor examples of how this works, because I say poor example because my grid power up here really should be over here somewhere by the pole. But in this example, the house is pulling about 2,340 watts. There's about 1,100 watts of solar available. It's going to pull the remaining 1,240 from the utility grid and blend it to power those loads, versus actually, disconnecting from the grid or powering it all. Now, if you have your state of charge set to, say, 50%, like we'll show in the example, and the battery's at 80%, then all 2,340 will come from the Rosie system. It will take It will take the extra from the battery if the battery is above the target at that moment. And the target can be voltage too. You get to pick that. So here's how we would go through and set this up. We would turn the charger on or off. That's a question, right? This is one of the first things I tell people is you have to decide, do you want the charger on or off? Personally, I run with the charger off because I know that I'm going to get enough sun to fill the batteries back up now and then, and I don't ever want to buy utility power to charge my battery. And I know that if I get in an issue where there's going to be a really nasty thunder shower or hurricane coming through, I can go out and I can turn my charger on and force a charge, disable grid support, and I can set that up kind of like storm mode, if you will. So you have to pick what's best for you. Do you want that to auto charge the batteries every now and then? Or if you've got lithium batteries and you really don't care, go ahead and turn that charger off. Set your float time low. This is another key for grid support. We talked about this already. And note that only the Rosie support follows the float time. So if you set float time to 30 minutes, for example, then your charge controllers will float the whole rest of the day. The Rosie is the only thing that goes silent. And the goal behind that is, again, to minimize usage of the grid, right? Like if you're charging a lead acid or a lithium battery and you use the grid to charge it through the Rosie, you want to get disconnected from that grid and let the renewables take over as soon as you can from a financial standpoint. So set that low. I usually set mine on my lithium for about 10 minutes. And then set your rebulk properly. This is if you're going to use the charger. So step 2, if the charger is off, you don't really care about rebulk, but if the charger's on, you do. In my case, rebulk is set for right around 25% of my lithium batteries, and that seems to work really well. And then you have to decide if you're doing state of charge based, grid support, or are you doing voltage based grid support. And that's really going to boil down to, does the Rosie have the ability to accurately know the state of charge, right? So if you've got the system set up correctly, you've got a whiz-bang junior in there, you've got closed loop, and you're comfortable with state of charge and you're finding it doesn't drift over time, you can certainly use that. It is a little bit more elegant. If you are using some lead acid batteries or a lithium that seems to drift over time, you can certainly use battery voltage. I've done that in the past with my EG4s. I've had really great luck. So, you have to kind of decide which one fits the bill the best for you based on the way the system is set up. And then what values do we want to use? How deep do we want to dig into the battery? And again, this is totally up to you, right? Like if your goal is to really minimize grid usage and you're like me where you have way more PV available during the day than you can use on loads during the day, if I started out the morning with a battery that was 90 to 95% full, my controllers would be in float and I'd be regulating by probably 10 a.m. and I'd be throwing power away. So I drain my batteries to 50% at night to give me room to put that power the next day. And what I've done is I've watched my system over, several weeks, and I've learned that like if I set it for 60%, I still go to float. I still regulate a lot of my controllers. At 50% seems to be a sweet spot where I don't really go to float much at all on my controllers, and I really maximize that. I still hit 100% most days, but I can really maximize that solar harvest during the day to reuse it during the night. So that grid support setting, that 50% setting, or the battery voltage that correlates to that, really boils down to two things: is how much room do you need in that tank every day to put that excess solar to store it for the next night? And then the other one is how much energy do you want stored in that battery if there is a power failure? If you live in a climate that gets frequent snowstorms or ice storms, then you may need to bump that number up. You may want to keep that a little bit higher to have a little bit more in reserve. If you live someplace like we do in Florida where there's not a lot of bad storms, other than maybe a passing thunder shower that knocks power out for an hour, 50% is a ton of power for us. We can get by quite a long time on that. So you have to balance that number, that 50%, for your needs. But really what we're trying to do in this application is to actually store every ounce of that solar power every day and then use it throughout the night. The goal is never to roll back over to that grid at 50%, of course. But if we do, then the next day we want to still be able to harvest every bit of that PV that we can harvest. And we talked about the reason to turn the charger off and on. We talked about setting float time. I said I set mine to 10 minutes, but you could set it to 30 minutes. Keep in mind that the float time is hours and minutes. All timers on the Rosie systems, Rosie, Hawke's Bay, and Barcelona's, are all 4-digit numbers, 00:30. And the first zeros are your hours, the second zero is your minutes. So that representation right there, 00:30 is 30 minutes. I've had some people think that was 30 seconds and set the absorb time or float time a lot longer. And then set your rebulk to whatever you're comfortable with. Again, in my case, 25-30%. And now what happens with the setup, just like you show here, with the charger on, float time 30 minutes, rebulk at 25, and grid support set to 50%. It'll run the battery down to 50%, powering loads. And then when it hits 50%, it will transfer back over to the grid. If you could watch it, there's about 20 spots there that it migrates back and forth. So what I mean by that is that like 50.9, 50.9% state of charge, all your loads are coming from the Rosie. At 50.8% state of charge, Rosie starts kicking back a little bit and using some of the grid. And then as it drops below 50% at 49.9%, all your loads come from the grid. So right at that teeter point of 50.0, the Rosie's going to basically balance and try to stay there. You, of course, only see whole numbers on the state of charge. But if you're using battery voltage, it's the same thing. Like, let's say you set it for 52.4. At 52.3, all loads come from the grid. At 52.5, all loads come from the Rosie. At 52.4, it'll share the two to try to maintain that 52.4. And then if you connect back to the grid, say at midnight, you've drained your battery down to 50%, and then there's no renewables for the next couple days, and the parasitic loads draw down on that battery until it's 25%, then we'll start a new charge. We'll do a complete charge, and then we'll go back into grid support again. So that's kind of the meat and potatoes of grid support. It's an elegant solution, but as I said, it does prioritize the charger over the grid curtailment. So that's something to keep in mind. And I'm not going to go over this. This is just something I put in here that, if you guys want to watch this video back when we post it, you could pause this here. But this is the, where you'd go to set these custom settings. So for example, to set grid support, setup button, inverter config, Rosie, grid support, and, you'd go in there and set these values. So LBX mode. LBX is probably one of my more favorite modes because it's very defined. There's no black. It is black and white. It's either using the grid or it's not using the grid. The only downside I have to LBX mode really is that it doesn't blend power. May not be a problem for most cases. Like I said, if you're running it that way, no real issue. It physically opens the relay. So when we hit our trip point, we're going to open the relay and ignore the utility grid until we reach our next trip point, which is a reconnect, and then we're going to go back and connect to the utility grid. So because of that, you have more flexibility on your charger too. But one thing to keep in mind is the LBX takes priority over the charger now. So with that in mind, if your charger is programmed, as you'll see here on the next page, we'll talk about it a little bit. But if the charger is programmed and you've got reconnect at 40%, disconnect at 40%, reconnect at like 80%, let's say, then what's going to happen is when you hit 40%, the relay is going to close, the grid is going to be present, the Rosie's actually going to recharge the battery on you until it hits that 80% and disconnect again. So in LBX, you really do want to disable the charger, in my mind. Otherwise, you're buying power to recharge the battery every time it reconnects. It does require you to use some of the battery to prevent cycling, whereas like in grid support, you could set it for 100% state of charge, and it would physically never let the battery go below 100%. It would always, blend the power and lead, fall back over to the grid. In LBX, you really can't do that. You need some delta between the disconnect and the connect. Otherwise, the relay would just sit there click-clack all day long and you wear the relay out. I believe we actually force you into, I think, 5% state of charge between the two as a minimum. I'd like to see more like 10% as a minimum myself, so that we just stay disconnected and we're not transferring back and forth. So because of that, it may not be as effective at using every bit of renewables as like grid support would be if you're trying to stay at a high state of charge. If you're trying to stay at a low state of charge, or if you're trying to drain the batteries down to like 50% every night, then it's a little easier to still use every bit of that. We talked about LBX does have priority over the charger. I think I explained that one. You set your rebulk ideally below the reconnected grid state of charge, but again, I recommend disabling the battery charger in LBX mode because it will actually start a charge when it connects. So here's kind of an example of this. You can see here when it's in LBX mode, all the loads are coming from the solar and the battery combined. So if there's no solar, it all comes from the battery. If there's enough solar, like say in this case, say it was 5,000 watts of solar, then we would send 2340 to the house and we'd send the other 2660, if I got my math right, to the battery to charge the battery. So you can actually charge or discharge the battery in that mode, from the solar. But the point is we're actually open the relay and we're actually ignoring the grid at this point. Something I do want to point out in this mode is that LBX is an absolute, just like time transfer is. So when you have told it to ignore the grid, the Rosie is going to ignore the grid, and it needs you to do some other steps if you want to not ignore the grid during like a low battery cutout situation or an overload situation. And the reason for that really is if you're in time transfer. In time transfer, we're telling the Rosie to ignore the grid because we're presumably saving you from paying 2, 3, 4, 5 times your normal utility rate during that, peak demand time. And the last thing we want to do is have the Rosie reconnect for whatever reason and use that grid. So we're sort of setting it up as the absolute is the mode. And then if you want to have it fall back over to the grid during an overload or a low battery cutout situation, low battery cutout should be automatic, but the overload, we have to enable what we call load exfer, and we'll talk about that here in a little bit. So here's some of the things that you would do in this mode, and you'll see they differ a little bit. Float time being set low is not really important in LBX because LBX takes priority over the battery charger. We discussed the pros and cons of the charger off and on. Personally, what I would do is I would program the Rosie up for all the proper charging setup you want, and then I'd turn just the charger off so that if I wasn't the end user, if I was the installer, I could leave a quick little sheet for you, the end user, that says press this button, do this, do this, do this, enable the charger, and now if you've got a storm coming, you'll have a full battery. It'd be pretty quick to explain that to them. And rebulk also is not as important because, again, as soon as it closes the relay, it would actually charge if you had the charger enabled. Other than that, it's all the same stuff, right? Like state of charge. Are we going to do closed loop state of charge? Are we doing open loop state of charge? Do we prefer to use battery voltage to trip this off and on, just like we did on grid support, right? That's totally up to you on how the system operates, what's the most balanced. If you're doing closed loop, like if our PowerFlow 5, state of charge is definitely the way to go. If you're doing a set of lead acid batteries and you don't feel you've got the Whiz-Bang Junior dialed in perfectly yet, do battery voltage. Set it up on battery voltage, and you can, tune that in just how you want. So what values do we want to use? And again, this is a lot like grid support, right? Like my personal recommendation on charger is off. You can turn it on here. For this example, I left it on because I wanted to show you what happens when you, when you set it up like this with the charger on. But I'd personally turn the charger off. I wouldn't worry about float time, and I would not worry about rebulk in this case. I would set LBX to go off grid at say 80% state of charge, and back on grid at 50% state of charge. So then what's going to happen with this example is the system is going to run with the relay open in an off-grid state, we'll call it, because it's ignoring the utility grid, and it's going to run until the battery drops down to 50% state of charge. When it hits 50% of state of charge, it's going to close the relay. the grid is going to run the loads. And if the charger is on, like it is in this example, the charger is going to come back on as well and charge the battery back up. So it'll keep charging until it hits this 80%, and then the relay will open, and it'll keep repeating that process, which is why I say you really don't want to run the charger in these modes if your goal is truly grid curtailment, right? Because you can see where at 50 and 80%, use my house as an example, a lot of times when we have heavy air conditioning loads and stuff in the evening, we go back on grid by midnight. So what would happen is we'd go back on grid at midnight, and then by 30 minutes later, we'd be at 80% state of charge because the battery charger was on, and then we go back off grid, and we'd stay off grid for, another maybe 30, 45 minutes, hour, and then we go back on grid, and that process would just continually cycle until the next day when the solar came up and was able to keep up. So you can see where I would be buying a lot of expensive power to just basically reuse it to power my loads very inefficiently all night long. So by turning the charger off, of course, we never buy power. We always prioritize, renewables first, battery second, and then we fall over to the grid just to run the loads, not to charge the battery. And that's going to be your absolute most efficient way, is to let, the Rosie power the loads from the solar and the battery, and never let Rosie charge the battery if you can help it, because that's buying power from the grid to charge the battery. So in my case, this is what I do, but I leave the charger off. So I go between LBX and grid support. I try them both. They both have their pluses and minuses. What I like about LBX mode is it's just on or off, and there's no teeter totter in the middle when you're falling over that 50%, which you won't really notice as an end user, but it's just easier. It opens the relay, it ignores the grid completely. There's never a chance of nuisance exports, which is pretty minimal in the Rosie. I will say this: we've got one running in Oregon that's been running for over a year in grid support mode, and the utility came out the other day and said over the course of 12 months they have logged 0.14 kilowatt hours of selling from the Rosie, and they're monitoring 100 times a second. My utility in Florida has never noticed it at all, but you will get a couple nuisance bursts of selling when you're in a grid support mode in any inverter. It's just the nature of how grid support works. So if you've got a co-op or a really, really picky utility, LBX is probably the way to go, because it's just absolute. The relay opens. There's no chance of anything going to the grid. Whereas in a grid support mode, you are actually selling a little bit to push the voltage up to overcome the utility to power loads. You're never exporting, or you shouldn't ever be exporting, but there is that nuisance export for a tenth of a second every now and then. And some utilities can see that. So again, with this one, setting your on grid at 50%, that 50% really comes down to the same thing we talked about before in grid support. How much energy do you want left in the storage tank for emergencies? And how much room do you need in that tank in the morning to push all that PV somewhere to store it for the following night? You may find that you only need to get down to 75. You may need to find you need to go deeper. So you just have to balance that for your particular system to really maximize the harvest of that PV array every day. And here's the settings for that. Again, not going to go through all of it, but this is available. You could pause it and watch it when we put this video up. And we'll be doing white papers on these modes as well. That'll be much more explanatory on. It'll have menu maps and show you how to get there, example programming, use cases, all that kind of stuff. So time transfer is our last one to talk about, and then we'll get you guys out of here today. It's a lot like LBX, except for it works on time of day, not the state of the battery. So it ignores state of charge, it ignores, battery voltage, and it literally works like an alarm clock. So you'll have a, time to go on grid and a time to go off grid. And between the going off grid and the going back on grid is your, blackout, if you will. I did mention before, but again, your time transfer takes priority over overloads. So if you do not enable load transfer as well, and you set up time transfer and you overload your Rosie, it's going to actually go into a fault and overload and shut down just like it would if it was off grid. It's not going to reconnect to that grid because it believes you don't want it to, because we've told it to not connect at any cost. So we need to make sure we enable that load transfer, and we turn the load transfer watts all the way up. And what that does then is, so say you set it for 7,000 watts on the load transfer. If the Rosie hits 7,000 watts, it will transfer over the grid. When the wattage falls below 7,000 watts, it starts a 5-minute timer, and then it connects back to the grid. The other thing that by doing that is you enable overload reconnect. And what that is if either leg of the Rosie overloads, it will force a reconnect to the grid as well. So because you set it for 7,000 watts, that's total wattage. If you put 5,000 watts on L1 and 0 watts on L2, you only have 5,000 watts of load. You will eventually overload the Rosie because you've overloaded one leg. And then what it does is it automatically reconnects to the grid as well. So that's something to keep in mind. Again, the low battery cutout should be automatic, but the time transfer has priority over the load transfer. So here's some stuff that we're going to need to do. And again, load transfer, I put this in here because this is important, because I've taken many calls on systems where the user is using time transfer instead of LBX mode, and then they run the battery dead, or they overload the Rosie and it doesn't go back over. So these are some things. The low battery cutout one was actually a bug that's being fixed as we speak, but the load transfer you have to enable. So you're going to go to setup, inverter config, Rosie. I forgot a Rosie in here. AC input control, and then you're going to look for load exfer, and you want to enable that. And then you want to turn that watts up. I would turn it up to the maximum of the Rosie. There's no downside, right? So I'd turn it up to 7,000 watts on a single Rosie. And all these numbers, as we go through here, like the load transfer wattage or the charger amperage, when you see an actual value in the Rosie, like charger amperage or breaker size or load watts, that's per Rosie. So if you've got 4 Rosies in the system and you set load transfer for 7,000 watts, that's 7,000 watts times 4 is what it needs to see before it transfers back over to the grid. So just keep that in mind. But once you enable load transfer, it automatically enables the reconnect to the grid on overload of either leg. So if you overload one leg of Rosie, it will automatically reconnect to the grid. And in time transfer, you would enable it, and then you have your transfer start and stop times, just like a clock, like an alarm clock. You set it hours and minutes, what time you want it to, open the relay, and what time you want it to close the relay. Pretty straightforward on that. And the one thing I do want to point out is the 5 to 6 minutes, because this was also brought up. When you do a load transfer to the grid, once that load falls below the target, a timer starts for 5 minutes, and it can be up to 6 minutes depending on where you catch it in the cycle. So it'll be between 5 to 6 minutes, and then it will open the relay and disconnect from the grid. So that's kind of that in a nutshell. I think, as I say, that brings me to the end of it. Those are really I would say 2 curtailment modes and 1 time of use mode. I don't really recommend the time transfer for grid curtailment unless you're trying to get around, peak cost during peak times. I would personally use LBX as my primary. Grid support is a secondary mode of curtailment if you have a more particular reason to use that mode. So we'll see if we've got any questions. Hopefully I didn't put everybody to sleep. And as I said, we will work on some presentations for the all-in-one and the batteries, as well as probably some more generic presentations about like the kits and the systems and the options, right? Because there's a lot of options now that we have that can be a little overwhelming. Closed loop versus open loop state of charge is a question. Again, if you're using open loop state of charge, you're using the Rosie and a Whizbang Junior. So there's a lot of factors that play into that, right? Like, have you programmed it correctly? Is everything working correctly? Did you miss a negative and it's on the wrong side of the shunt? So you need to make sure that the state of charge is tracking correctly before you just enable everything, right? Like if it's a brand new install, run it through its paces, put a known load on it, run it down, see if the state of charge makes sense to you, and then go ahead and enable this stuff, right? Like, because if you say you put the charge control on the wrong side of the shunt can't measure that. It'll never know that you're refilling the battery, and it'll just keep, gradually going downhill until it goes to zero. So closed loop is, of course, much more elegant because it's a number given to the Rosie directly from the battery. So we're just trusting the battery at that point. Open loop is a lot a lot for you to program. Not a lot, but it's things that you have to program: battery efficiency, battery capacity, etc., and making sure you get that all right. Does the Rosie have UL 1741 SB cell to grid? So the Rosie does not have SB. The Rosie will actually sell to the grid right now, but it's not a listed, grid cell inverter. It does have the 5-minute timer and all the other stuff in anti-islanding, but it has not been through, to get SA or SB. It is on the roadmap. I just don't know exactly where that is. I think that might be about it. We'll get more. Could the grid connection be used to link up an existing working solar power system as input to the Rosie? Yes, it actually could. I'm working through one right now, which is a dual stack of Outbacks feeding a dual stack of Rosies. What I would suggest if you're going to do that, though, is rather than using like a grid support or LBX mode on the Rosie, I would use the other system that's feeding it. So, for example, like on the Outback inverter, you have a 2-wire connector that you can open, and the Outback quits making AC. I would drive that from the Outback's AGS, and I would set it up such that, if the battery is above 70% state of charge, or pick your poison, it'll close that contact, turn the AC out on the Outback on. The Rosie will automatically recognize that and use that. And then when the battery falls below a target, we can break that connection and shut that AC out off. So it's going to depend a lot on what you have in place for an existing system to feed the Rosie, but there's many ways to do that. And that's a very common practice now, especially with a lot of the older 12 and 24 volt systems and people just upgrading with the 48 volt all around. If there's a hydro or something involved, it makes a lot of sense. Our utility is now switched to requiring UL 1741 PCS CRD for battery inverters, not accepting 1741 SB anymore. It's good to know. I will pass that info on to engineering. How much power can one leg of a Rosie handle? So for 24 hours a day, 7 days a week, the Rosie can do 110% of 3,500 watts on one leg. So it can run, what would that be? That's too much math for my head right now, but like 3,800 watts, I think it is, on one leg forever. It can run up to about 3 times that for a split second to start a load, and then there's this linear line down between those two, right? Like if you ran 4,000 watts, it would probably run for about 30 minutes. If you run 5,000 watts, it might run for 10 minutes on one leg. So yes, and info at Midnite Solar, I do get that email. So if you do want to follow up with me on that, connecting the two systems together, just address me in the email. It goes to our whole support team, but I will, or you can just change the info to Ryan at midnitesolar.com. Happy to jump in there, get you my phone number if you want to jump on the phone and have a call, or you can call that number on the screen and ask for me. That works too. But we're definitely open to discussing those systems. So. All right, I think I'm going to go ahead and wrap this up, and we will go from there. Like I said, keep an eye on Sue's Constant Contacts. We'll be doing a lot more stuff coming forward. We're going to try to do this every couple of weeks on some subject. It may be batteries, it may be pre-wired systems, it may be classics if we get the demand. If you've got any feedback on what you'd like to have us present on, again, info at midnitesolar.com. Shoot us an email. We'll work on that. I definitely can put together presentations and give them, no problem. So yeah, we just need to know what direction to go. We appreciate everybody taking your time out and setting in our webinar. And if you get any questions, feel free to reach out. And we hope to see you in the next one. Thank you all for attending.